Alright, students. So in our last class, we talked about titration, which is a process to figure out unknown concentration of an acid or a base by using the known concentration of the other one. So if you wanted to figure out the unknown concentration of an acid, you have to use a standard or known concentration of a base. And we can figure out one of the unknown concentration by using the titration formula, which is given in your reference table T, MABA equals MBBB. So please make sure to have your reference table in front of you as we go through today's lesson. So in this slide, we have two Erlenmeyer flux. We'll start with the first one on our left side. Let's assume that in this Erlenmeyer flux, we have an unknown concentration of an acid. So the concentration of the acid is unknown. We have to figure it out. And let's assume that the volume of the acid is 100. Right? So the volume of the acid is 100 milliliters. So we know the volume, and to figure out the concentration of the acid, we need to use a standard base, meaning we have to know the concentration of a base. And in the burette, we can fill out the burette with the base. So we can use the burette to drop bases in the Erlenmeyer flux. And the starting point of the burette, in this case, it starts at, and then you have all the way up here. Let's just say you have till 50, right? So we don't know the volume of the base yet till we complete the titration, right? Till we see the endpoint and we see a color change. But the only way you can see a color change if you're using an indicator, otherwise you have to use a pH meter. So let's just say we are using an indicator, phenolphthalein. So we have to add that indicator to this Erlenmeyer flux. So we're adding an indicator. And if you don't remember the indicators and the range of the indicators, please look at reference table M. So in this case, phenolphthalein is going to be colorless in an acidic solution. Usually acidic solution has a pH of less than 7. And then this indicator will turn pink in a basic solution. So as we are adding base to our Erlenmeyer flux, if we have phenolphthalein as an indicator, as the base hits the acid in the Erlenmeyer flux, we're going to see a pink color, right? But the pink color is not going to be stable for a while till it reaches the endpoint. And if we pass beyond endpoint, obviously the solution color is going to be pink because we're now going to have a basic solution. And in that basic solution, if you have a phenolphthalein indicator, the solution color is going to be pink. If you don't remember what I'm talking about, this was discussed in our previous video for titration. And it's also in this picture, where we can see the colors, right? So when it's an acidic solution, the indicator won't show any color because phenolphthalein is colorless, anything that has a pH of 8 or below. And then as the base hits the solution, right, as we're having a base, pouring base to the acidic solution, we'll see pink color in our acidic solution, but it's going to fade away because the solution is still acidic even though you had a drop or two of base, right? And then eventually when we reach the endpoint is where we're going to see a color change. The solution is going to be slightly pink. This is we need to realize that we should stop because the all acids have been neutralized. And if you don't realize that, or if you keep adding bases for some reason, it would go way too far. And now that the solution is basic, the pH phenolphthalein indicator will indicate the color pink because the solution is no longer acidic, neither neutral. It became a basic solution because you have added way too much basic solution in it, right? So let's say we are using an indicator phenolphthalein, which will turn the solution pink. By the way, I just wanted to make it very clear that this solution should not be red. It should be very clear, right? It's transparent. But just wanted to show you guys that we have something in it. So I will just add this. Right. So assume that this is my acidic solution. And when the endpoint was reached, the solution is going to turn slightly pink, right? So let's say now I have this solution, which is not transparent anymore. It's slightly pink. And the volume is above 100, right? So the solution that we used, the standard solution, basic solution that we used, it's let's just say 2 molars, 2 molar of sodium hydroxide solution. So we know the volume, the concentration of the base, and we can figure out the concentration of the base by using um, the starting and end point from the burette reading. So if you look at the burette reading, we started from 0, right? That's where we started from. And after we reach the end point, you can see the color change. We have to take the reading again. And let's just say now I have this amount of base left in the burette. So if we started from 0 and we ended at 40, then the volume of the base that we use for this titration is going to be 40 minus 0, which is 40. That's why majority of the people during acid-base titration experiment, they start with 0 reading so that it's easier for us to calculate. But you don't have to do that. So we know the molarity of the base, which is 2 molar. We also know the volume of the base that we use for titration, which is 40, to reach our endpoint, right? So we reached our endpoint, got a slightly pink solution. So now we have every single information to calculate our concentration for the acid. And to calculate the concentration for the acid, we have to use our titration formula. So what is our titration formula? Our titration formula is MaVa equals MbVb. You can find this formula in reference table T, where Ma is the concentration of the acid, Va is the volume of the acid, Mb is the concentration of the base, and Vb is the volume of the base. I usually write my given on the right side, and in the given part, I don't know Ma, so that is not given. I'm still going to write it down with a question mark. Va was, I have to go back and check. It was 100. So VA was 100 milliliters. Then I have to look for MB and VB. Remember, you're only solving for one unknown at a time. So MB was 2 molar and VB was 40. So MB was 2 and VB was 40. So now I'm solving for MA, which is the concentration of the acid. VA, I'm just going to replace the uh, symbols for values. So VA would be 100. MB is 2 and VB is 40. So 100 MA equals 40 times 2, which is 80. So what would be the volume of MA? You have to divide, what would be the, um, we have to calculate MA, so we have to divide both sides by 100 to isolate MA. And if we do that, these will cancel each other out. So MA is going to be 80 over 100, which is 0.8. And that's how we can figure out the unknown concentration of an acid by using the standard concentration or known concentration of a base. We usually use Burette to figure out the volume of the acid or base for the standard concentration, and you can use graduated cylinder to figure out the volume of the acid, right? Especially during an experiment. Now, let's solve Regents' questions regarding titration. So here the question says how many milliliters. So I'm looking for volume of 4 molar. So that's always look at the units. So that's your concentration. NaOH. So what is NaOH? You should look at reference table K and L to figure out which one is an acid, which one is a base. So NaOH, you can most probably find it in reference table L, which is a base. So I know that the concentration of the base is given, right? Mb is given, and the volume of the base is unknown. So as I'm reading the question, I usually write down what is given. So I don't know the volume of the base, but I do know the concentration of the base, which is 4. Now that means everything about acids must be given. So here it says 50 milliliters, so that's another volume. So that's the volume of the acid. 2 molar, so that's the concentration of the acid. And if you're thinking about how do I know it's acid, you can always use your reference table to figure out what is HNO3, right? Which is an acid. Also, if in the beginning part of the question it says how many milliliters of 4 molar NaOH, sodium hydroxide, and you identified sodium hydroxide as a base using your reference table L, that means HNO3 has to be an acid. So it's the opposite, right, in a titration problem. So don't rush to solve these questions. Always write down the formula by using your reference table T. So you're going to write MAVA equals MBVB. And then you're going to replace those letters with the values that you have on your right side, right? So MA is 2. I usually use parentheses for every single value. VA is 50. equals MB is 4 and VB is unknown. So here 2 times 50, we have 100 equals 4 VB, and then you have to isolate VB by dividing both sides by 4. And if you do that, the volume of the base is going to be 100 divided by 4, which is 25. And in this case, it would be 25 milliliters because we use milliliters as an unit for this question. So I hope you understood the concept of titration, and at this point, you should be able to solve some questions regarding titration. There will be an online assignment for titration, and where you can practice some titration problems to check your own understanding. In the essay-based packet that was given during class, and also it was posted on Google Classroom website, you have a couple of questions regarding titration as a practice problem. I highly recommend you to practice those questions in your packet before you go and submit your online assignments. Right? This is it for acid-based unit. We are going to talk about next unit in our next video lesson.